Here we are at example 4 from our 8.4 set of notes. We're asked to simplify this following rational function. And in just looking at him, we notice that we can go ahead and factor the top as well as the bottom. When we factor out the top, it comes out to be x squared minus 4 times x squared minus 1. And we can factor this further, but we'll do the bottom for now as well. When we factor out the bottom, we notice that we have kind of a polynomial here that, because of the amount of terms that we see, we're probably going to have to do a factor by grouping here. And in just looking at these two, I'm probably going to go ahead and split it up. Maybe we'll try here and see what happens. Now, if we were just to look at this first piece, we can go ahead and pull an x squared out. And we would be left then with x minus 1. Because we could go ahead then and distribute this back to get our original. Over here, I'm going to go ahead and jot down a plus symbol right in front of that negative 4x. In doing so, we have not changed the second piece at all. It's pretty much just like saying 5 minus 4. Well, that's the exact same thing as saying 5 plus negative 4. So by having that in there, I'm going to use it actually as a placement. So really we have plus negative 4x plus 4. And we can actually go ahead and take out a negative 4x from both pieces. I'm sorry, a negative 4 from both pieces. So we pull a negative 4 out, we would be left with just regular x. And then if we pull a negative 4 out of positive 4, we'd be left with negative 1. And you could distribute this back to see if it matches our original. So we've pulled out, again, that negative 4 from both terms. So negative 4 times x minus 1. Going ahead and factoring this further, just looking at this x squared minus 4, we see that we have the difference of two perfect squares. We can break that down into x plus 2 times x minus 2. This x squared minus 1 is also a difference of two squares. Perfect square, difference of these two perfect squares. And when we break that down, it comes out to be x plus 1 times x minus 1. On the bottom, what we can do is we notice we have a common x minus 1. We can actually pull that x minus 1 out of both of these terms. And when we do that, we end up with x minus 1 on the outside times whatever was left over when we pulled out that x minus 1. In this one, it'd be x squared. When we pull an x minus 1 out of the second piece, we were just left with negative 4. Factoring this bottom one even further, we end up with, we actually have x plus 2 times x minus 2 on top still, times x plus 1 times x minus 1, all over x minus 1 times, really on the bottom, this x squared minus 4 is the difference of, again, two perfect squares. So that's x plus 2 times x minus 2. And now we can go ahead and start canceling things off. Looks like the x plus 2's can drop out, x minus 2's can drop out, x minus 1's can drop out. And so the only thing that we're left with is that x plus 1 on top. Notice it is on top as well. There's nothing left on the bottom. So our final answer just comes out to be x plus 1. Now, in the past, I've heard questions such as, well, I have this x squared minus 4. Eventually, the bottom also has an x squared minus 4. And do I necessarily have to factor each of these items out? I've heard this a few times. And my best advice for you is to factor things as much as possible, because for two reasons. One, it's improving your factoring skills. But two, you can actually see things broken down as much as possible. Okay? And you can see the actual cancellations start to happen and how everything is then canceled. So my advice to you is, yes, you could have left this and eventually this, and then they would have dropped on top. But again, my advice to you is really get in the habit of just breaking everything down as much as possible and seeing the cancellations happen one by one. Again, though, that is example 4 from our 8.4 set of notes.